Okay, so today we are going to continue working with row operations in row echelon form, but we get to make our own decisions about which operations we should do in order to get it into row echelon form. Tomorrow you're going to have a quiz with one question. I'm going to give you a system of equations, whether it be 2 variable or 3 variable, and you're going to use a matrix and row operations to solve it. Okay? Please write down this system, or this matrix, I guess. Now, I do want to give you this warning that when you're doing this by hand, depending on the steps that you take, your row echelon form could look different than somebody else's row echelon form, except for the last row. The last row will always be the same, okay? But when you represent it as a system of equations, it should still work out to be the same x, y, and z, okay? But sometimes the row echelon forms could look just slightly different based on the actions that you take, okay? So our goal, if we're getting into row echelon form, is to get a diagonal of 1s and 0s below, okay? So look at this matrix and have a discussion at your table. What could be a move we could make in order to get something to happen? Okay, who has an idea from their table they'd like to share? I can call on you, that's fine. Okay. Okay, adding row 2 and row 3 together would make what happen?
You cancel out the x's.
Okay, you get a 0 first, right? And you'd also get a 1, wouldn't you? Okay. Did anybody else have a different idea? Okay. So you want to take row 2 plus row 3 for your new row 2?
Yep.
Okay, so if we add those two together, we would get 0, 1, 3, 5. Okay? And really, row 2 is good now, isn't it? We want it to be 0, 1, and that's what we have. So now what we need to focus on, we need our first row to begin with a 0, and we need our second row, or our third row, to begin 0, 0, 1. Okay? We don't have to get that accomplished all at the same time, but we do know that we can switch rows, we can multiply rows by a number, and we can add multiples of a row to another. Okay? I hear somebody whispering the word switch. Okay, row 3 begins with 1, right? Let's make it row 1, because we want row 1 to start with a 1. So, we can take row 1, switch it with row 3, and now we have 1, negative 2, 3, 9. 17. Please be careful with your organization. Make sure everything stays in rows and columns, okay? Also be sure that you're writing legibly so you don't copy down a number incorrectly from your work above, okay? Because doing writing down one number incorrectly could screw up everything else. Okay? All right. So now row 1 is good. Row 2 is good. We need to focus on row 3. Okay? Now I'm going to tell you this right now. If you're going to make multiple zeros in a row, you need to start with the very left entry and make it a 0 before you make the next entry 0. Like if I try to make this entry 0 right here, it's not going to be helpful. We need to start by making this entry 0 first, and then our next step could be to make the next one 0. Okay? So if we want to make this entry right here 0, is row 2 going to be helpful for us? Is row 1 could be helpful for us? Okay. What could we multiply row 1 by? -2. We could take row 1, multiply it by -2, and add it to row 3. Now I know that we're multiplying row 1 by -2, but we don't actually have to write that down. We're going to keep row 1 as is because it's helpful. Okay? We want it to be 1, blah, 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 blah. But if we multiply it by -2, we'd have -2 times 1 plus 2. -2 times -2 plus -5. -2 times 3 plus 5. And then -2 times 9 plus 17. -1. That worked out kind of nice. Okay. We're so close, aren't we? Okay, now we need our last row to be 0, 0, 1. Is row 1 going to be helpful for us? No, because we've already done this work to make this 0. The only row that could be helpful to us is row 2. It's actually really helpful, isn't it? To make this number a 0, what operation can we do? Yeah, we can add, multiplying it by 1 essentially keeps it the same, right? So we can really just add 2 and 3 together, couldn't we? Okay, so I'm going to notate that. I'm going to take row 2, add it to row 3, and that's my new row 3. Okay, we are so close. Yes, I know that you can tell right now that z is 2. I know that. But it is my expectation, listen very carefully, it is my expectation that if you use an augmented matrix to solve a system, you better get it all the way to row echelon form. Or I will take off one. Okay? So row echelon form means we would need to take row 3 and multiply it by 1/2. How many steps did that take us? 5? Okay, took us 5 steps to get that 3x4 augmented matrix into row echelon form. Okay, now I gave you this matrix, but let's say it represented a system. If it represented a system of equations, what does this mean right here? Z equals 2. This row right here would mean y plus 3z equals 5. What's y? Y y is negative 1. This row up here would mean x minus 2y plus 3z equals 9. So if that represented a system, 1, negative 1, 2 would be our answer. Okay, what do you think? It's a lot of writing numbers, yes, it is. But do we really have to do any algebra? And that's exciting to some of you, I know. We did a lot of algebra in chapter 7, didn't we? Like an overwhelming amount of algebra in chapter 7. Now we get to just write down numbers and play with numbers a little bit. Okay? Go ahead and write down this system of equations for me, please. Now, in our last example, excuse me while I change slides very quickly. In our last example, I gave you a matrix. And so really just getting to the row echelon form matrix is all I needed you to do. We talked about if it represented a system, this is what we would need to do. But since I gave you a matrix, our answer was technically the matrix. Now here, I'm giving you a system. What kind of answer am I looking for? Well, what is the answer to a system? A coordinate, okay? So when I give you a system, you can use a matrix to solve, but your answer needs to be written as a coordinate, okay? So first, let's go ahead and write this as an augmented matrix. Go ahead and have a discussion. Don't do any row operations, but brainstorm a little bit, at least one or two or more ideas that you have about maybe first step, second step, and what we could do to get this into row echelon form. All right. Emma, what are some ideas that your table had?
You said that you could multiply the top one by -1 and add it to the bottom one to get the first common.
Okay. Any other ideas that you had? Or is that just kind of where you stopped?
Well, and then I said you could multiply the bottom row by -1/3 to get the second one.
Okay. So, and as I was walking around, I heard a lot of people talk about this one. Multiplying the first row by a -1 so that you could add it to the second row to replace the second row. Raise your hand if you had that same idea. How many of you said negative row 2 to add to row 1? Okay, doesn't matter. It doesn't matter. Okay. So let's go with this one. If we take negative row 1 and add it to row 2, we would get 0, negative 3, negative 9. Now, in order to get this into row echelon form, we're really close, aren't we? We need that first row to begin with a 1. We need the second row to be 0, 1. So watch this. What would we need to multiply the first row by? Row 1 can be multiplied by 1/2. Huh? Do you think that we could do that in the same step? I think so. I think that we can do that in the same step and be perfectly fine. Now, technically, this is as far as I would need you to take it. However, when you have a 2-variable system, once you get it into row echelon form, it's only one more step to get it into reduced row echelon form. What would we do to get this into reduced row echelon form? Reduced row echelon form would mean this is a 0 right here. Row 1 plus negative row 2, add it to row 1. Is that what you said?
No, I said, I think I meant negative 3, row 2, and then add it to row 1.
Yeah, I'll rewrite it because it looks kind of weird. Negative 3 row 2, adding it to row 1 would get us 1, 0, negative 1. And bam, we know that negative 1, 3 is our coordinate. Okay? In a 2-variable system, it only takes you one extra step to get it into reduced row echelon form. But as long as you get it to row echelon form, that would be my minimum requirement. I'm just telling you that, hey, it's only one more step and then you have to do 0 algebra. Okay? But as long as you get it into row echelon form, I'm perfectly happy. Okay? I am going to show you how to do this on your calculator, but tomorrow's quiz will be by hand. And I will tell you straight up, I'm going to give you one problem, either a 2-variable system or a 3-variable system, and you're going to put it into an augmented matrix and do row operations by hand so you can tell me what the coordinate is. Okay? But it is possible that we have a 4-variable system or a 5-variable system, and I'm not going to expect you to do any of that by hand. So let me show you how to do it in a calculator. Okay? Okay, so first of all, I need to show you where the matrix menu is. Okay? Oh. I was trying to get this bigger. Okay. So I'm going to get my calculator out. It's like a giant. So let me get this. Okay, hello. This is Helen's children again. Let's put it over here. Okay. So, do you see the second button? Press it. And then this button right here, do you see how it says matrix above it? Hit it. That's your matrix menu. Second matrix, you're going to make that keystroke a lot. Okay? In our matrix menu, here are all of our matrices. They're given a name. We can do operations with them, and we can edit them. Okay? If you want to get out of the matrix menu, then press second quit, which is the button right next to second, and it takes you back to the original screen. Okay. So what we're going to do is we are going to input this system into our calculator. So let me show you where to go, and then I'll bring this back up. Okay? So, let's see. If we go to our second matrix menu, I want you arrow over to edit, and it doesn't matter which matrix you edit, but my suggestion would be with each new problem, you change A. A is the easiest to call up. So go ahead, and when you're under edit and A is highlighted, press enter. It's going to ask you for the order of your matrix. What's the order of our matrix? I heard mumbles. 3 by 4. So enter 3, enter 4, enter. And do you see how it gives you 3 rows and 4 columns? Okay. So everybody in your calculator. Does anyone not have their calculator today? Grab one so you know what we're doing, okay? In your calculator, enter in those numbers. Make sure you use the negative sign, not the subtraction sign. We have those numbers entered in. Okay. Quit out. So second quit. You're back to the home screen. Are you ready? Go back to your matrix menu. I want to do something with my matrix, so we're going to go to math. You don't know what any of these mean, but keep scrolling down. And do you see these ref and ref? REF and RREF? What do you suppose REF stands for?
Row echelon form.
Row echelon form. Monique, what does RREF stand for? Reduced row echelon form. If we're using our calculator, which one is going to be the most beneficial? Reduced row echelon form. So go ahead and hit it. Okay, do you see how it opens a parentheses? That means something needs to go inside. Which matrix did I have you enter numbers into? So go back to matrix, and where it says names, as long as A is highlighted, you can hit enter, and it'll pull it up. Ready for the magic to happen?
That's pretty cool.
Anybody not get it? You're working on it. All right. What does this mean about our system? Yep. Yep. Okay. So if I give you like a 5 variable system, you can put it in your calculator and boom, get the answer. Okay. Now I know that punching in the numbers is tedious. However, especially in like a 4 or 5 variable system, that's gonna save you some time. Okay. So it is my expectation that you follow the directions of the book assignment. First of all, ignore anything that says Gauss Jordan. Just do the methods that I taught you. Okay, do elementary row operations. If it says use a calculator, use a calculator. Okay? My only warning to you is that remember row echelon form could look different for different people. So don't try to like check your row echelon form in your calculator because it's not going to necessarily give you the same matrix. It'll give you the same XYZ, but it won't give you the same matrix. Okay? So we have 10 minutes left. And I know this is kind of different, so I want to give you 10 minutes to at least do a problem, maybe one of each kind, one with your calculator, one without your calculator, to make sure we can work out some of the kinks before I send you to do this at home. Okay? So whether you have just one book at your table open for everyone to share, you need help with your calculator, let me know.